Today, we are diving deep into something really exciting, running a powerful, private AI right on your own computer. Seriously, imagine it. No cloud, no subscriptions, just pure AI horsepower that you control.
I mean, have you ever really thought about that? The power to have a conversation, to write code, to create a story with an AI that lives entirely on your hardware? It's a total game changer. And believe it or not, it's way more accessible than you'd think.
So, why would you even bother with all this? Well, there are three huge reasons. First up, privacy. When you run an AI locally, your conversations, your data, it never leaves your machine. It's all yours, period. Second, cost. Yeah, you have to have the hardware, but after that, running the models is free. And third, customization. This is the cool part. You can tweak these AIs to be absolute specialists at pretty much anything, from creative writing to super complex coding.
All right, so to get all those benefits, you first got to understand the one piece of tech that makes this whole thing tick.
And that piece of tech is the large language model, or just LLM. The easiest way to think about it is as the brains of the operation. This is the massive, complex file that does all the heavy lifting, all the thinking. It's the thing you'll actually download and run.
So how do you get one of these AI brains up and running? I know it can seem kind of intimidating with all the jargon out there, but we're going to break down the key ideas you absolutely need to know. Let's put together our starter kit. First thing you'll hear about is something called a fine-tune. See, a base model from a big company is a great start, but then developers can take that model and train it on more specialized data. This is how you get all these different flavors. Some are amazing at conversation, others are math wizards, and some are coding geniuses. It's where the real magic of customization starts.
Now this next concept, this is what makes running these things on a regular computer even possible. It's called quantization. LLMs are naturally gigantic files. We're talking huge. But quantization is this really clever process that basically compresses them, shrinking the file size way down so it can actually fit in your computer's memory. And usually, it only comes with a tiny trade-off in performance.
And this chart really lays out those trade-offs perfectly. You'll see models measured by their parameters in the billions, like 7B or 70B. And yeah, as you can see, a 70 billion parameter model is generally a whole lot smarter than a 7 billion one. But just look at the full file size, a whopping 140 gigabytes. That's where quantization becomes our hero, taking that massive file and shrinking it down so we can actually use it.
So when you're browsing for models to download, you're going to see these different file formats. Think of them kind of like zip or RR files just for AIs. Now, if you're just starting out, the one you want to look for is GGUF. It's super flexible because it can use both your main computer processor, the CPU, and your powerful graphics card, the GPU. It's just a great, versatile place to start. Okay, so you've picked your model, you're all set to go, and then you smack right into the single biggest problem in running these things locally. And it's not what you think. It's not about processing power. It's a massive data traffic jam.
And this chart says it all. New research shows that when you're doing big AI tasks like loading up a new model, the actual thinking part, the compute time, is incredibly fast. It's that tiny bar. The problem, the giant bar, is just moving all the data around. Getting the model's information from your computer's main memory over to your graphics card can take up a staggering 90% of the total time.
And the reason for this is actually pretty simple when you picture it. That connection between your system's RAM and your GPU's special memory, it's basically a single-lane tunnel. It doesn't matter how fast your GPU is, all that data has to get squeezed through one narrow path to get there.
And look, this isn't just a metaphor. Researchers have put it in black and white. This single-lane tunnel, known as PCI, has become the critical bottleneck holding back performance. It's why loading models can feel so slow, and why it takes a moment for the AI to start talking back to you.
But what if you could break out of that single-lane tunnel? What if instead you could build a data superhighway? Well, that's exactly what some new research is all about. This is the solution.
It's a new technique called multipath memory access, or MMA, and it completely flips the script. Instead of trying to shove all that data down one single lane, it's smarter. It intercepts the transfer, breaks the data into little pieces, and then shoots those pieces across every available data path in your system, all at the same time.
And the result? It's nuts. A massive increase in bandwidth. We're talking a peak data transfer speed that was over 4.5 times faster than the old-school single-path way. That's not just widening the road. That's turning a single-lane country road into a multi-lane superhighway.
So what does that actually feel like for you? Well, it has a direct impact on your experience. That time to first token, which is just how long it takes for the AI to start its reply, gets way faster. And model switching time, which we already know is a huge bottleneck, gets up to 2.5 times faster. It just makes using a local AI feel snappy and fluid.
Okay, so we've gone through the basics and we've looked at a really cutting-edge solution. Let's pull it all together and see what this actually means for the future of your own personal AI.
So here's the rundown. First, running AI on your own machine is getting easier and more accessible every single day. Second, we now know the biggest technical hurdle isn't raw power. It's that data traffic jam. Third, amazing new tech is building data superhighways to blast right through that bottleneck. And what that all leads to is a future where we can run even bigger, even more powerful AI models right on our own machines.
And you know, at the end of the day, these breakthroughs aren't just for research papers. They're directly leading to a way better experience for us, the users. They're making that dream of having a truly powerful, totally private, personal AI assistant a real, tangible thing.
Which leaves us with one last, really exciting question. As these tools get faster and more powerful and easier to use, the old limitations just start to melt away. So the only question left is, what are you going to build with it?